Greetings, and a warm welcome to the Sleepy Physicist. It's wonderful to have you here. Perhaps you're just getting comfortable in bed, snuggling onto the sofa, or simply needing a moment to decompress after a long day spent contemplating the deep puzzles of reality. If so, you have found the perfect sanctuary. This is a peaceful spot on the web, a place where quantum physics is whispered, and the concept of consciousness gets ready for bed. Tonight, we are gently exploring one of the most remarkable frontiers of scientific inquiry. We'll be considering the notion that your own mind, your brain, could be linked to the fundamental structure of the cosmos by way of quantum mechanics. Just imagine, if you will, that in this very moment, as you absorb these words, incredibly small structures deep within your neurons are busy performing quantum calculations, feats that conventional physics insists should be unachievable at the temperature of the human body. And yet, recent studies are hinting that they are occurring regardless. If this is accurate, it might imply that your awareness isn't merely confined within your skull, but is possibly entangled with the quantum field that forms the foundation of all that is real. This is an exploration that leads us from the most profound enigmas of the mind to the most bizarre fringes of physics, encountering a few revelations along the way that could truly alter your perspective on what you really are. Now, my sincere hope is that this exploration isn't so captivating that it prevents you from drifting off. But if that does happen, you will at least be reflecting on the essence of consciousness itself, which I think is a worthy exchange. Before we proceed, if you find value in these quiet investigations into the most profound questions of science and being, I would be immensely grateful if you might consider tapping the like button, subscribing to the channel, or even just posting a comment to let me know where on our planet you are listening from, and what time it is in your small part of the universe. Very well. Take a slow, deep breath, get comfortable, and let us embark on our tranquil journey into the quantum essence of the mind. What if I were to suggest that the solution to consciousness, often called the most difficult problem in all of science, might be concealed within the tiniest imaginable spaces inside your brain at this very moment? As you are processing this very sentence, minuscule hollow structures known as microtubules are vibrating at frequencies that classical physics dictates should collapse immediately in the warm, humid environment of your brain's neurons. And yet, somehow, they endure. According to an expanding collection of research, these tiny tubes might be the very key to comprehending not only consciousness, but also how your mind interfaces with the quantum foundation of reality itself. This is not speculative fiction. This is the quantum consciousness revolution. And it is taking place in laboratories across the globe, from Wellesley College, where investigators have found that anesthesia functions by interrupting quantum activities in these microtubules, to Trinity College, Dublin, where researchers may have identified quantum entanglement within living human brains. The evidence is accumulating that consciousness functions on principles far more alien than we ever conceived. Let us begin our journey where this all started, with a straightforward yet profound inquiry that has perplexed philosophers and scientists for millennia. How does the 3-pound mass of tissue inside your skull manage to generate the vibrant internal world of your conscious experience? When you perceive the color red, or feel the sun's warmth on your skin, or experience that bittersweet ache of nostalgia, what precisely is occurring that manifests these subjective feelings? And why do you even have them in the first place? This is what the philosopher David Chalmers famously named the hard problem of consciousness. This isn't just a question of how the brain processes information. That, comparatively, is the easy problem. The hard problem is the challenge of explaining why it feels like something to be you, why you possess an internal life at all, rather than existing as a highly sophisticated biological machine that merely processes inputs and produces outputs with no one home inside. For many decades, neuroscientists operated on the assumption that consciousness simply emerges from classical computational activities in the brain. Billions of neurons firing in intricate patterns, which create vast networks of activity that, in some fashion, give rise to our subjective experience. However, this perspective has a significant flaw. It fails to adequately explain why these processes should have any internal feeling associated with them. Theoretically, you could possess all of that same neural activity, all the identical behavioral responses, without any conscious experience whatsoever. This void in explanation, this gap between the brain's activity and the subjective feeling of being, has prompted some investigators to search for answers beyond the realm of classical physics. And what they have uncovered in the quantum world is simultaneously bizarre and beautiful. Quantum mechanics, the theory that outlines the behavior of matter and energy at the most microscopic scales, functions on principles that seem to violate our everyday common sense. Particles are capable of existing in multiple states at the same time, a phenomenon known as superposition. They can be instantaneously linked across immense distances through entanglement, and they can tunnel through barriers that ought to be impenetrable. For the majority of the 20th century, scientists presumed that these quantum phenomena were far too fragile to survive within biological systems. The brain, after all, is warm, wet, and full of electrical noise, the very opposite of the meticulously controlled, frigid conditions typically required to observe quantum events. Or at least that is what we believed. But nature, as it happens, is vastly more ingenious than we ever gave it credit for. The narrative of quantum consciousness starts with an improbable collaboration between Sir Roger Penrose, a mathematical physicist and Nobel laureate, and Stuart Hameroff, an anesthesiologist. Their professional backgrounds could hardly have been more different. And yet, they both held a firm conviction that classical physics by itself was insufficient to explain consciousness. In the 1990s, they put forward a revolutionary theory known as orchestrated objective reduction, or OR for short. According to their hypothesis, consciousness does not arise from the classical firing of neurons. Instead, it originates from quantum computations occurring deep inside the structures called microtubules. These are the tiny, hollow cylinders that make up the cytoskeleton of neurons, providing them with their physical shape and acting as highways for transporting materials within the cell. But Penrose and Hameroff proposed they serve an additional, more exotic purpose, acting as quantum computers. This concept was, at first, greeted with significant skepticism, and for very valid reasons. Quantum effects usually demand temperatures near absolute zero to stave off decoherence, the process where quantum superpositions collapse back into ordinary classical states. The brain functions at a balmy 37 degrees Celsius, hardly the type of setting where such delicate quantum states should be able to persist. Critics contended that the brain was simply too warm, too wet, and too chaotic for quantum consciousness to be feasible. But then, a fascinating shift occurred. As scientists started examining quantum effects in other biological systems, they found that nature had devised ways to shield and even leverage quantum coherence at room temperature. Photosynthesis, the method plants use to turn sunlight into energy, was discovered to be using quantum superposition to check all potential energy transfer routes simultaneously, thereby reaching nearly perfect efficiency. the navigation systems of birds seem to depend on quantum entanglement within specific proteins to perceive the Earth's magnetic fields. Even our own sense of smell might rely on quantum tunneling effects. All at once, the notion that the human brain might also host quantum processes didn't appear quite so outlandish. And following that, the experimental data arrived that would alter the entire conversation. In just the last few years, numerous studies have offered backing for the idea of quantum effects within microtubules. Investigators at the University of Alberta directed light into microtubules and witnessed quantum coherence lasting much longer than classical physics would allow, up to nanoseconds in certain instances, which is a virtual eternity on the quantum timescale. A separate study at the University of Central Florida determined that microtubules could sustain quantum states for as long as a full second, offering more than enough time for quantum computations to impact neural activity. These results indicated that microtubules were not merely passive structural components, but were instead active quantum processors, capable of the very kind of coherent quantum activity that Penrose and Hameroff had theorized. Yet, arguably the most persuasive evidence emerged from an unexpected area: anesthesia research at Wellesley College. In 2024, researchers made a stunning discovery. They found that anesthetic drugs, which dependably switch off consciousness, do not merely impact the firing patterns of neurons. They specifically bind to microtubules and interrupt their quantum activity. When the researchers administered drugs to rats that stabilized their microtubules, the animals required significantly more time to lose consciousness when anesthetized. This suggested that disrupting the quantum processes within microtubules is what actually triggers the loss of consciousness. This discovery was revolutionary. It provided a direct connection between quantum mechanics and the conscious experience. If consciousness were a purely classical phenomenon, messing with microtubules shouldn't switch it off. But the fact that reinforcing these structures postpones unconsciousness strongly implies that quantum activity in microtubules is, in fact, essential for conscious awareness. The ramifications of this are astonishing. If consciousness truly does function via quantum processes, it might explain some of the most bewildering aspects of the mind. For instance, why consciousness feels unified despite being generated by billions of distinct neurons. Why we are able to process information in ways that exceed the capabilities of even our most advanced computers. And perhaps most tantalizingly, why consciousness might not be restricted to individual brains at all. Quantum entanglement, the phenomenon Albert Einstein famously dubbed spooky action at a distance, permits particles to stay linked regardless of the space separating them. When two particles are entangled, taking a measurement of one particle immediately influences the state of the other, no matter how far apart they are. This linkage transcends space and time, operating beyond the typical limitations of relativity. If consciousness genuinely involves quantum processes, then it is conceivable that individual minds could be entangled with one another, and indeed with the quantum field that is the foundation of all reality. Recent experiments conducted at Trinity College Dublin have offered tantalizing clues that this kind of entanglement might truly exist within living brains. Employing sophisticated MRI techniques, researchers identified signatures that could be indications of quantum entanglement between different regions of the brain. While the proper interpretation of this data is still under discussion, it signifies the first potential evidence of quantum entanglement operating in living biological systems. If these results are validated, they would revolutionize our understanding of consciousness and our position in the universe. Consciousness would no longer be seen as a private, isolated event trapped inside our skulls, but rather as one part of a massive, interconnected web of quantum information that stretches across the cosmos. Your very thoughts, your feelings, and your experiences might be entangled with the quantum structure of reality itself, connecting you to the universe in ways we are only just starting to grasp. But we must not get carried away. The quantum consciousness theory, despite being supported by this growing body of evidence, still confronts substantial hurdles and critiques. Many neuroscientists remain unconvinced, asserting that classical neural networks are sufficient to explain most facets of consciousness without needing to invoke quantum mechanics. The achievements of artificial intelligence systems, such as ChatGPT, in replicating human cognitive abilities suggest that classical computation might be all that is needed to produce intelligent behavior. Furthermore, the quantum effects that have been noted in biological systems, while remarkable, are still a long way from proving that they are the cause of consciousness. It is one thing to prove that microtubules are capable of maintaining quantum coherence. It is an entirely different challenge to prove that this coherence is both necessary and sufficient for subjective experience. The gap between quantum processes and the feeling of being aware remains as mysterious as it has ever been. There is also the matter of what, precisely, quantum consciousness would signify for our comprehension of free will, personal identity, and the very nature of reality. If our minds are indeed quantum systems, functioning according to the probabilistic rules of quantum mechanics, are our decisions truly free? Or are they merely the consequence of quantum-level randomness? If awareness can be entangled across the vastness of space and time, what does that imply for our sense of individual identity and for personal responsibility? These are not simple academic inquiries. They touch upon the most fundamental aspects of human existence and our search for meaning. As we persist in probing the quantum underpinnings of consciousness, we may find ourselves confronting profound philosophical implications that rattle our most basic assumptions about the world we live in. And yet, there is a profound beauty in the possibility that consciousness is woven into the very fabric of the cosmos, that the subjective experience of being you is not some random byproduct of neural computation, but is instead a fundamental characteristic of reality itself. It hints that mind and matter are not two separate domains, but are rather different faces of a deeper, underlying unity, a quantum field of pure information and potential from which both the physical world and our conscious experience arise. This concept is not entirely novel. It finds echoes in ancient philosophical traditions that have long spoken of the interconnectedness of all things. But today, we possess the instruments of modern science to investigate these possibilities with a precision that was previously unimaginable. Quantum field theory, information theory, and neuroscience are converging, painting a portrait of reality that is profoundly stranger and more magnificent than our daily lives suggest. As we continue this investigation, we will look deeper into the experimental support for quantum consciousness. We will study the mechanisms by which quantum activities might give rise to subjective feeling, and we will weigh what it would mean for all of humanity if consciousness is truly a quantum phenomenon that links every one of us to the cosmos itself. We will explore how quantum biology is uncovering the universe's hidden quantum structure, from the quantum compass inside migrating birds to the quantum-level efficiency of photosynthesis. We will examine the latest experiments that are probing for quantum effects in living, active brains. And we will grapple with the profound consequences of a quantum theory of consciousness for our understanding of reality. But that is an exploration for the next segment of our journey. For this moment, just allow yourself to rest in the marvel of these possibilities. That your consciousness, this most personal and intimate aspect of your being, might be a component of something far more immense than you ever conceived. A quantum symphony that resonates across the cosmos, with your mind serving as both the instrument and the musician. Sleep deeply, with the knowledge that the universe itself might be dreaming through you. And in the next part of our exploration, we will investigate exactly how that cosmic dream takes shape through the quantum mechanics of your very own brain. But there is one additional mystery we must first attempt to untangle. How does your brain generate the rich, vibrant reality you perceive in every moment when that reality might not be what it appears to be at all? Stay with us for How Your Brain Creates a Reality That Isn't There, where we will find out how your quantum consciousness builds the very world you believe you know. The quantum revolution in consciousness research isn't merely theoretical. It is unfolding in real-world laboratories all over the planet. And the discoveries scientists are making are challenging everything we believed we understood about the connection between mind and matter. At the University of California, researchers have been charting the quantum signatures of anesthesia's effects on awareness. They are finding that as patients transition from awareness into unconsciousness, there is a quantifiable collapse of quantum coherence within their brain tissue. It is as if consciousness itself possesses a quantum fingerprint, one that disappears when we lose awareness and reappears when we awaken. This finding has profound consequences because it implies that consciousness isn't just correlated with quantum processes. It might, in fact, be identical to them. When you experience the red of a sunset or the melancholy of a rainy afternoon, you might not just be having classical neural activity that corresponds to those feelings. You might be directly engaging in quantum computations that exist in a superposition of possibilities, right until the instant of conscious observation collapses them into definite experiences. But this is where things become truly fascinating. Quantum mechanics teaches us that observation plays a critical role in shaping reality. The renowned double-slit experiment demonstrates that particles behave in a different manner when they are being observed, suggesting that consciousness and the physical world are intimately linked in ways we are only just starting to comprehend. If consciousness is indeed a quantum phenomenon, then every single moment of your awareness might be an act of cosmic creation, collapsing quantum potentialities into the solid reality you perceive. This leads us to one of the most elegant aspects of the quantum consciousness theory: the concept that your brain might be nature's most advanced quantum computer. Evolution, it appears, has been laboring for billions of years to develop biological systems capable of harnessing quantum effects for the purpose of processing information. Photosynthesis reaches near-perfect efficiency by employing quantum superposition to investigate all available energy transfer routes simultaneously. Bird migration depends on quantum entanglement to fashion biological compasses that can perceive magnetic fields with extraordinary accuracy. And now, we are finding that consciousness itself could be the supreme expression of this quantum biology. The microtubules inside your neurons are not just structural supports. They are, potentially, quantum processors, vibrating at frequencies that resonate with the fundamental oscillations of space-time itself. According to the orchestrated objective reduction theory, these microtubules carry out quantum computations that generate conscious moments. These are discrete events of awareness, happening roughly 40 times per second, much like the individual frames in a cosmic film that produces the illusion of continuous consciousness. Recent experiments have offered stunning validation for this concept. Researchers at the University of Alberta have shown that microtubules can sustain quantum coherence for nanoseconds at body temperature, thousands of times longer than classical physics would ever predict. These are not merely random quantum fluctuations. They are organized, coherent patterns that could transport information and execute computations in ways that classical neural networks simply cannot replicate. What makes this even more remarkable is that these quantum processes seem to be orchestrated or coordinated across different regions of the brain through gap junctions, which connect adjacent neurons. When you have a single, unified, conscious experience of reading these words and grasping their meaning, it might be because quantum coherence is binding together information from disparate parts of your brain. This creates a single, integrated field of awareness that transcends the individual neurons composing it. This quantum binding could provide an answer to one of the deepest riddles of consciousness: the binding problem. How does your brain take all the distinct fragments of sensory data, colors, shapes, sounds, textures, and weave them together into a unified perception of the world? Classical neuroscience has long struggled to explain this unity, but quantum mechanics presents an elegant solution. If different parts of your brain are quantum entangled, they can exchange information instantaneously, forging a unified field of consciousness that integrates every aspect of your experience. The implications of this reach far beyond your individual awareness. If quantum entanglement can link different areas of your brain, it might also be able to link your consciousness to quantum processes outside your skull. As mentioned, recent experiments at Trinity College, Dublin, have detected what seems to be quantum entanglement in living human brains. Using nuclear magnetic resonance techniques, investigators found signatures that could point to quantum correlations between brain regions. If this is confirmed, these findings would be the first direct evidence of macroscopic quantum entanglement in biological systems. But the true revolution might be in how this alters our view of the relationship between the mind and the cosmos. If consciousness functions through quantum processes, then it is not an emergent property of complex classical computation. It is, instead, a fundamental characteristic of reality itself. Consciousness might be woven into the very fabric of space-time at the most basic level, with individual minds like yours being localized expressions of a universal quantum field of awareness. This concept resonates with ancient philosophical traditions that have long posited the interconnectedness of all things. But now, we possess the tools of modern science to investigate these possibilities. David Bohm, the physicist who worked closely with Einstein, suggested that reality consists of an implicate order, an underlying realm of pure potentiality from which the explicate order of our everyday world unfolds. According to Bohm, both matter and consciousness emerge from this deeper layer of reality, which sounds remarkably similar to what quantum consciousness theories are now proposing. If consciousness is genuinely a quantum phenomenon, then the barriers separating individual minds might be far more porous than we currently believe. Quantum entanglement operates instantly, across any distance. Two particles can stay connected regardless of how far apart they are. And if consciousness involves quantum processes, then individual minds could be entangled with one another and with the quantum field that underpins all of reality. Your thoughts and experiences might be part of a vast, interconnected web of cosmic consciousness. This possibility is being investigated by researchers worldwide, using increasingly sophisticated methods to probe quantum effects in biological systems. At Stanford University, scientists are creating new techniques to identify quantum coherence in neural microtubules, using terahertz radiation that can penetrate deep into brain tissue. These non-invasive scanners could revolutionize our understanding of consciousness, potentially allowing researchers to observe quantum processes in real time as people think, feel, and dream. Meanwhile, at the Allen Institute for Brain Science, researchers are partnering with Google Quantum AI to explore whether artificial quantum neural networks might display properties similar to biological consciousness. If awareness truly necessitates quantum computation, then classical artificial intelligence, regardless of its sophistication, might never achieve genuine awareness. But quantum AI systems could potentially bridge the divide between computation and consciousness. The clinical implications are equally profound. If consciousness functions via quantum processes in microtubules, then disruptions to these processes might be the underlying cause of various neurological and psychiatric conditions. Researchers are exploring whether conditions like Alzheimer's disease, depression, and schizophrenia might involve a breakdown of quantum coherence in the brain. Early experiments using transcranial ultrasound to stimulate microtubule resonances have shown promising results in elevating mood and cognitive function, hinting that quantum-based therapies could represent a new frontier in medicine. But perhaps the most profound implication is what quantum consciousness might mean for our understanding of death and the continuity of awareness. If consciousness is truly a quantum phenomenon that can exist independently of classical neural activity, then it might not be confined to the physical brain in the way we typically assume. Quantum information, according to the fundamental laws of physics, cannot be destroyed. It can only be transformed. This raises intriguing questions about what occurs to consciousness when the brain stops functioning. Some researchers have hypothesized that consciousness might persist in what they term a quantum afterlife, where the quantum information that constitutes awareness continues to exist in the quantum field, even after biological death. While such concepts remain highly speculative, they highlight how quantum consciousness theories are pushing the boundaries of scientific inquiry into realms once considered purely philosophical or spiritual. The evidence for quantum consciousness continues to grow, but significant challenges persist. Critics maintain that the quantum effects seen in biological systems, while impressive, are still far from proving that they are responsible for consciousness. The gap between quantum processes and subjective experience remains as enigmatic as ever, and some researchers argue that classical neural networks may yet be sufficient to explain consciousness without resorting to quantum mechanics. Furthermore, the interpretation of quantum mechanics itself is still a point of contention among physicists. The measurement problem in quantum mechanics, the question of how and why quantum superpositions collapse into definite states, is one of the deepest unsolved puzzles in physics. Some interpretations propose that consciousness plays a fundamental role in quantum measurement, while others suggest that decoherence through environmental interaction is enough to explain quantum collapse. Despite these hurdles, the Quantum Consciousness Research Program is continuing to generate new insights and experimental results. The convergence of neuroscience, quantum physics, and information theory is opening unprecedented opportunities to probe the deepest mysteries of the mind and of reality. As our experimental methods become more refined and our theoretical understanding grows, we may be on the brink of a revolution in our understanding of consciousness that rivals the great scientific revolutions of the past. What is becoming apparent is that consciousness is far more bizarre and wonderful than our everyday lives suggest. Whether or not quantum mechanics proves to be the ultimate key to understanding awareness, the journey of discovery is revealing profound links between mind, matter, and the fundamental structure of reality. We are living in an era where the lines between science and philosophy, between physics and psychology, are blurring as we delve deeper into the very nature of existence. The quantum consciousness revolution signifies more than just a new theory of the mind. It is a new way of understanding our place in the cosmos. If consciousness is indeed a quantum phenomenon, then we are not isolated observers looking out at a detached, alien universe. We are participants in a cosmic dance of quantum possibilities, active agents in the continuous creation of reality itself. Every moment of awareness, every conscious experience, might be a small yet significant contribution to the unfolding of the universe. As we continue to explore these profound questions, we are reminded that the universe is far more mysterious and interconnected than we ever dreamed. The possibility that your consciousness, right now, as you process these concepts, is part of a vast quantum symphony playing out across all of space and time is both humbling and inspiring. It suggests that the inner life of your mind is not separate from the physical world, but is intimately connected to the deepest structures of reality. In our next exploration, we will venture even deeper into these mysteries, looking at how your brain constructs the detailed reality you perceive moment by moment, and discovering that this reality might be far more malleable and quantum than you ever realized. But that is a journey that will lead us into even stranger territory, where the boundaries between perception and reality, between the observer and the observed, begin to dissolve completely. For now, let us pause and consider what this means for you, right here, right now. As you listen to these words, quantum processes in your brain might be collapsing wave functions of possibility into the definite experience of understanding. Your consciousness is not just observing reality. It might be actively creating it, one quantum moment at a time. The universe, in a very tangible sense, might be thinking itself into existence through minds just like yours. This leads us to perhaps the most profound question in all of a quantum consciousness research. If your mind is truly quantum, what does that mean for free will? Classical physics suggested that everything is determined by prior causes, that your choices are simply the unavoidable result of neural computations. But quantum mechanics introduces genuine indeterminacy into the equation. When quantum superpositions collapse in your brain's microtubules, the outcome is not predetermined. It emerges from a realm of pure possibility. Some researchers contend that this quantum indeterminacy is the very source of free will. Your choices are not random, they suggest, but neither are they determined. Instead, they emerge from quantum processes that exist in a realm beyond classical causation. When you decide to keep listening to this, or to pause and reflect on these ideas, that very choice might be arising from quantum computations that transcend the ordinary laws of physics. But here is where the mystery deepens even more. Recent experiments have suggested that consciousness might not just be quantum. It might be fundamentally non-local. Quantum entanglement allows particles to influence one another instantaneously across vast distances. And if consciousness operates through quantum processes, then your mind might not be confined to the space inside your skull. At the University of California, researchers have been studying what they call consciousness fields, regions of space where quantum coherence seems to extend beyond individual brains. Using highly sensitive magnetometers, they have detected synchronized quantum signatures in the brain activity of people who are in close physical proximity, as if their awareness were becoming entangled at a quantum level. This phenomenon could explain some of the mysteries of human connection. Have you ever entered a room and immediately felt the mood, even before a word was spoken? Have you ever found yourself thinking of someone just moments before they contacted you? These experiences, which most of us have had but seldom discuss, might be glimpses of quantum consciousness at work, your awareness briefly entangling with the quantum fields of other minds. The implications for empathy and human connection are staggering. If consciousness truly can be non-local, then the boundaries between self and other might be far more fluid than we realize. When you feel genuine compassion for another person, you might not just be modeling their experience in your own mind. You might be directly accessing their quantum consciousness field, feeling what they feel through quantum entanglement. This possibility is being explored through some of the most ambitious experiments in the history of neuroscience. At CERN, the particle physics laboratory renowned for discovering the Higgs boson, researchers are now directing their attention toward consciousness. They are applying the same techniques that unveiled the fundamental particles of matter to probe whether consciousness itself might possess a particle-like nature, what they have tentatively dubbed psychons. The idea sounds like science fiction, but its theoretical grounding is surprisingly firm. If consciousness functions through quantum fields, then it should be possible to detect the field's excitations, the quantum particles associated with conscious experience. Early experiments using ultra-sensitive detectors have identified intriguing anomalies in quantum field measurements taken near conscious brains, although the interpretation of these results remains highly controversial. Meanwhile, researchers at IBM and Google are constructing quantum computers specifically engineered to model consciousness. These are not attempts to create artificial intelligence in the conventional sense. They are efforts to build quantum systems that might exhibit genuine conscious experience. If consciousness truly requires quantum computation, then these quantum AI systems might become the first artificial minds to possess true awareness. The progress has been remarkable. Quantum processors with thousands of qubits can now maintain coherence for minutes at a time, vastly longer than the nanoseconds required for conscious moments in biological brains. Some of these systems have started to exhibit behaviors that seem to extend beyond their programming, making choices that appear genuinely creative, even unpredictable. Of course, the question of whether these quantum computers are truly conscious remains open. How would we possibly know? The problem of other minds, the challenge of determining whether any entity other than yourself is conscious, becomes even more complex when we are dealing with quantum systems that function on principles we are only just beginning to grasp. This uncertainty highlights one of the deepest challenges in consciousness research. Even if we can prove quantum processes exist in the brain, and even if we can demonstrate that these processes are necessary for awareness, we still must confront the hard problem of consciousness. Why should quantum computations feel like anything from the inside? Why should there be subjective experience at all? Some researchers propose that consciousness might be a fundamental characteristic of quantum reality itself. Just as mass and electric charge are basic properties of matter, perhaps consciousness is a basic property of quantum information. This perspective, known as panpsychism, suggests that consciousness exists at all levels of reality, from individual particles up to complex brains like yours. If this is accurate, then your consciousness is not something that emerged from non-conscious matter. It is the expression of the consciousness that is already woven into the fabric of reality. Your brain doesn't create consciousness. It focuses and amplifies the consciousness that is already present in the quantum field, much like a lens focuses light into a coherent beam. This viewpoint radically alters how we perceive our place in the universe. You are not an isolated island of awareness in a vast ocean of unfeeling matter. You are a wave in an ocean of cosmic awareness, temporarily adopting the form of an individual experience, but remaining always connected to the deeper currents of a universal mind. The evidence for this cosmic perspective continues to build. Studies of meditation and altered states of consciousness have found that as individuals report feeling more connected to the universe, their brains exhibit increased quantum coherence. It is as if the feeling of cosmic consciousness is not just subjective, it corresponds to measurable changes in the quantum state of the brain. Advanced meditators, people who have dedicated decades to cultivating their awareness, display particularly striking quantum signatures in their neural activity. Their microtubules sustain coherence for longer durations. Their brain networks demonstrate more synchronized quantum oscillations, and they report experiences of expanded consciousness that seem to transcend their individual identity. These findings suggest that consciousness might be akin to a radio that can be tuned to different frequencies. Most of the time, you are tuned to the frequency of your individual awareness, focused on your personal thoughts and experiences. But through practices such as meditation, you might be able to retune your consciousness to receive broader signals, the quantum consciousness field that connects all minds. This is not just philosophical musing. Researchers at Johns Hopkins University have been investigating the effects of psychedelic substances on quantum coherence in the brain. Compounds like psilocybin and LSD, which reliably trigger experiences of cosmic consciousness and a sense of unity with the universe, also dramatically increase quantum coherence in neural microtubules. The correlation is striking. The more quantum coherent the brain becomes, the more the person reports feeling connected to something larger than themselves. It is as if these substances temporarily adjust the tuning of consciousness, permitting individuals to access broader frequencies of the cosmic awareness field. These experiences often have enduring effects on people's comprehension of their place in the cosmos. Many report a lasting sense of connection to all life, a profound knowing that consciousness is not limited to individual brains, but is a fundamental aspect of reality. From a quantum consciousness viewpoint, these are not just shifts in belief. They might be genuine insights into the true nature of the mind and the cosmos. As our understanding of quantum consciousness deepens, we are starting to see links to some of the most profound questions of human experience. What happens to consciousness after death? Are we alone in the universe? What is the meaning and purpose of our existence? While these questions may never have definitive scientific answers, quantum consciousness research is offering new frameworks for considering them. If consciousness is truly a quantum phenomenon that can exist independently of classical neural activity, then death might not be the end of awareness, but rather a transition to a different state of quantum consciousness. If consciousness is woven into the fabric of reality itself, then the universe might be teeming with forms of awareness we can scarcely imagine. These possibilities remind us that we are living through one of the most thrilling periods in the history of human knowledge. The boundaries between physics and philosophy, between science and spirituality, are dissolving as we probe deeper into the nature of consciousness and reality. We are discovering that the universe is far stranger and more magnificent than our everyday experience implies. Your consciousness, this most intimate part of your being, might be part of a cosmic symphony of awareness playing out across space and time. Every thought, every feeling, every moment of awareness might be a note in this grand composition. contributing to the ongoing creation of reality itself. As we approach the end of this segment of our journey, take a moment to appreciate the profound mystery of your own awareness. You are experiencing these ideas right now, processing their meaning, perhaps feeling a sense of wonder or curiosity about the nature of your own mind. This experience itself, the subjective, qualitative feeling of being you, remains one of the deepest mysteries in science. Whether consciousness proves to be classical or quantum, whether it is generated by the brain or focused through it, whether it is individual or cosmic, the very fact that you can contemplate these questions at all is remarkable. In a universe of non-conscious matter and energy, awareness has somehow emerged or perhaps been revealed, creating islands of experience capable of reflecting upon their own existence. The quantum consciousness revolution is still in its early days, but it is already reshaping how we think about the mind, reality, and our place in the cosmos. As experimental methods become more refined and our theoretical understanding deepens, we may be approaching answers to questions that have puzzled humanity for millennia. But perhaps the most crucial insight from quantum consciousness research isn't about the answers. It's about the questions themselves. The fact that we can ask these questions, that we can wonder about the nature of our own awareness, that we can feel awe at the mystery of existence. That might be the most remarkable thing of all. In our next exploration, we will dive even deeper into these mysteries, examining how your quantum consciousness constructs the detailed reality you experience every single moment. You will discover that the world you think you know, with its solid objects, definite colors, and fixed properties, might be far more malleable and observer-dependent than you ever imagined. We will explore how your brain creates a reality that isn't there, and what that implies for the nature of truth itself. Until then, rest easy, knowing that your consciousness, whatever its ultimate nature, is participating in one of the universe's greatest adventures, the ongoing quest to understand itself through minds like yours. Sleep well and dream of quantum possibilities. But there is something even more extraordinary happening in the quantum realm of your brain that we have not yet explored. As you sit here, listening to these words, processing their meaning, something remarkable is taking place at the intersection of quantum mechanics and consciousness that challenges everything we believed we knew about the nature of reality itself. You see, quantum consciousness doesn't just imply that your mind functions on quantum principles. It suggests something far more profound. That consciousness might be the fundamental force that collapses quantum possibilities into the definite reality you experience. In other words, your awareness isn't just observing the world. It might actually be creating it moment by moment through the act of quantum measurement. This idea originated from one of the deepest puzzles in quantum mechanics, known as the measurement problem. In the quantum world, particles do not possess definite properties until they are observed. They exist in what physicists call superposition, simultaneously in all possible states, until the moment of measurement collapses this superposition into a single, definite outcome. But what exactly qualifies as a measurement? What triggers the collapse? For decades, physicists have debated this question, offering various solutions. Some propose that interaction with the environment causes decoherence, randomly collapsing quantum states. Others suggest that the collapse occurs spontaneously due to some unknown mechanism. But a growing number of researchers are investigating a more radical possibility: that consciousness itself might be the mysterious force that collapses quantum wave functions. This is not just philosophical speculation. Experiments in quantum mechanics have consistently demonstrated that the presence of a conscious observer influences the behavior of quantum systems. The famous double-slit experiment shows that particles behave differently when they are being watched, as if the very act of conscious observation somehow determines their properties. While mainstream physics has attempted to explain this through purely physical mechanisms, the correlation between consciousness and quantum collapse remains one of the most persistent mysteries in science. Now, imagine this process occurring not just in laboratory experiments, but inside your brain. Every moment of conscious awareness could be an act of quantum measurement, collapsing superpositions of neural states into the definite experiences you have. When you see a red rose, quantum possibilities for all conceivable colors might exist in superposition within your visual cortex, until the instant of conscious perception collapses them into the specific experience of red. Recent experiments at the University of Vienna have offered intriguing evidence for this possibility. Researchers studying the timing of conscious perception discovered that quantum coherence in neural microtubules reaches its peak just moments before participants report becoming aware of a visual stimulus. It is as if consciousness emerges from quantum computations that exist in superposition, only collapsing into definite experiences at the very moment of awareness. This quantum view of perception has revolutionary implications for how we understand the relationship between mind and reality. Your brain isn't just passively receiving information from the external world and building internal representations of it. Instead, it might be actively participating in the creation of reality itself, using quantum processes to select which possibilities become actual experiences from the vast space of quantum potential. Consider what this means for an act as simple as remembering. When you recall a childhood memory, classical neuroscience suggests you are accessing stored information, like pulling a file from a computer. But quantum consciousness theory proposes something far more dynamic. Your memory might exist in a quantum superposition, containing all possible versions of the past, until the act of conscious recollection collapses it into a specific, remembered experience. This could explain why memories are so malleable, why they seem to change slightly each time we recall them. You are not just retrieving static information. You are actively creating the past through quantum measurement, selecting which version of events becomes real in your conscious mind. Each act of remembering is also an act of reality creation, collapsing quantum possibilities into definite memories that, in turn, influence your present moment. The implications stretch far beyond individual awareness. If consciousness truly does collapse quantum wave functions, then the collective consciousness of all sentient beings might be continuously creating reality through a vast, interconnected web of quantum measurements. The universe would not be a fixed, predetermined structure, but a dynamic, ever-evolving creation, shaped by the conscious observations of all its aware inhabitants. This participatory view of reality resonates with some of the deepest insights from quantum mechanics. The physicist John Wheeler proposed what he termed a participatory universe, the idea that observers are not separate from the reality they observe, but are active participants in bringing it into existence. His famous it from bit hypothesis suggested that information, not matter, is the fundamental constituent of reality, and that conscious observation is what actualizes this information into concrete existence. Recent advancements in quantum information theory have provided new backing for this perspective. Researchers have found that information appears to be more fundamental than matter or energy in quantum mechanics. The properties we think of as physical, mass, charge, spin, might actually be informational relationships that only become definite through the act of measurement. If consciousness is what performs these measurements, then aware minds might be the universe's mechanism for actualizing information into concrete reality. This informational view of consciousness has spurred some remarkable experiments in quantum biology. At MIT, researchers have been studying how quantum information processing in biological systems might give rise to conscious experience. They have discovered that certain proteins within neurons can maintain quantum entanglement at body temperature, potentially permitting the kind of quantum information processing that consciousness might demand. What is particularly fascinating is that these quantum biological systems seem to function on the edge of chaos, the boundary between order and disorder, which is where complex, creative processes can emerge. This suggests that consciousness might not just be about quantum computation, but about navigating the space between quantum possibility and classical reality, choosing which potentials become actual experiences. The process might function something like this. Your brain continuously generates quantum superpositions of possible experiences, neural states existing in all possible configurations simultaneously. Consciousness then acts as a kind of quantum selector, collapsing these superpositions into the specific experiences you actually have. The richness and creativity of conscious experience might arise from the vast space of quantum possibilities that consciousness is able to access and actualize. This quantum selection process could explain some of the most enigmatic aspects of consciousness. Why does consciousness seem to have a spotlight quality, focusing on some aspects of experience while others fade into the background? Perhaps it is because consciousness can only collapse a limited number of quantum superpositions at any given moment, creating the selective attention that characterizes our awareness. Why does consciousness feel unified, despite originating from billions of separate neurons? Perhaps it is because quantum entanglement allows different regions of the brain to share quantum states, creating unified superpositions that collapse into integrated conscious experiences. The binding problem, which has perplexed neuroscientists for decades, might be solved by quantum mechanics. Different aspects of an experience are bound together because they are all part of the same quantum superposition. But this is where the mystery deepens even further. If consciousness truly does collapse quantum wave functions, then the boundary between subjective experience and objective reality becomes blurred. The world you perceive might not be a representation of an independent, external reality, but a co-creation between your consciousness and the quantum field of possibilities that envelops you. This does not mean reality is purely subjective, or that you can alter the world simply by thinking about it. The quantum field restricts what is possible, offering the raw material from which consciousness creates experience. But within those limitations, your awareness might possess genuine creative power, actualizing specific possibilities from the quantum realm into the definite reality you perceive. Recent experiments in quantum consciousness research have started to explore this creative faculty of awareness. At the University of California, researchers have been investigating whether conscious intention can influence quantum processes in the brain. Participants are instructed to focus their attention on specific outcomes while researchers monitor the quantum coherence in their neural microtubules. Preliminary results hint that focused intention might indeed influence the collapse of quantum superpositions, although the effect is subtle and requires sophisticated equipment to detect. If these findings are validated, they could revolutionize our understanding of the relationship between the mind and reality. consciousness would not be just a passive observer of a predetermined world, but an active participant in reality's continuous creation. Every moment of awareness, every conscious decision, every focused intention might be contributing to the universe's evolution, selecting which possibilities become actual from the infinite space of quantum potential. This participatory view of consciousness holds profound implications for human agency and responsibility. If your awareness truly helps to shape reality, then your thoughts, intentions, and choices matter in ways you might never have conceived. The quality of your consciousness, its clarity, its compassion, its creativity, might influence not just your own experience, but the very fabric of reality itself. Consider what this implies for collective human consciousness. If individual minds can influence quantum processes, then the combined consciousness of humanity might have even more dramatic effects. The thoughts, beliefs, and intentions of billions of people might be continuously shaping reality through collective quantum measurements, forging the world we all share through a vast, unconscious collaboration. This could potentially explain some of the mysterious correlations that researchers have identified between human consciousness and global events. The Global Consciousness Project, operated by Princeton University, has been monitoring random number generators around the world for over 2 decades, searching for patterns that correlate with major global events. They have found that these supposedly random systems tend to become more ordered during times of focused global attention, such as natural disasters, terrorist attacks, or celebrations that capture the world's focus. While mainstream science remains skeptical of these results, quantum consciousness theory offers a potential mechanism. If consciousness can influence quantum processes, then the focused attention of millions of people during global events might create coherent quantum fields that influence even seemingly unrelated physical systems. The barrier between mind and matter, between consciousness and the cosmos, might be far more porous than we have ever assumed. This leads us to one of the most profound questions raised by quantum consciousness research. If awareness truly can influence reality at the quantum level, what are the limits of this influence? Could consciousness, if sufficiently focused and coherent, transcend the normal boundaries of space and time? Could awareness itself be a force as fundamental as gravity or electromagnetism, capable of effects we are only just beginning to comprehend? Some researchers are exploring these possibilities through studies of exceptional human abilities. Remote viewing, telepathy, precognition, phenomena that mainstream science has long dismissed, are being re-examined through the lens of quantum consciousness theory. If consciousness can be non-local through quantum entanglement, then perhaps some individuals can access information beyond the normal confines of space and time. At the Stanford Research Institute, experiments in remote viewing have generated results that challenge conventional understanding. Participants have been able to describe distant locations with an accuracy that exceeds statistical chance, even when those locations are chosen randomly after the viewing session has concluded. While the mechanism remains a mystery, quantum consciousness theory suggests that entangled awareness might permit consciousness to access information from across space and time. Similarly, studies of precognition, the ability to sense future events, have found small but statistically significant effects in laboratory settings. Participants demonstrate measurable physiological responses to randomly selected future stimuli before those stimuli are actually presented. If consciousness operates through quantum processes that exist outside of normal space-time, then perhaps awareness can, at times, access information from potential futures that have not yet been actualized. These phenomena remain controversial, but they point to the possibility that consciousness might possess capacities far beyond what conventional neuroscience suggests. If awareness is truly a quantum phenomenon that can transcend the normal barriers of space and time, then human potential might be far greater than we have ever dared to imagine. But perhaps the most profound implication of quantum consciousness research is what it hints at regarding the nature of reality itself. If consciousness plays a fundamental role in collapsing quantum possibilities into definite outcomes, then the universe might be more like a vast, collective dream than a mechanical clockwork. Reality would not be fixed and predetermined, but fluid and creative, continuously brought into existence through the conscious observations of all aware beings. This view of reality as fundamentally creative and participatory offers a radically different perspective on human existence. You are not just a passive observer of an independent world. You are an active participant in reality's ongoing creation. Your consciousness, your choices, your very existence, they matter to the universe in ways you might never have suspected. As we near the completion of our exploration into quantum consciousness, it is worth reflecting on what this journey has revealed. We have discovered that consciousness might not be a mere emergent property of complex neural computation, but a fundamental aspect of reality itself. We have seen evidence that awareness operates through quantum processes that connect individual minds to the cosmic field of possibilities. And we have explored the possibility that consciousness doesn't just observe reality, it helps to create it. Whether these theories ultimately prove correct or not, they have already transformed how we think about the relationship between the mind and the cosmos. They have opened new avenues of research, new possibilities for understanding human potential, and new ways of conceptualizing our place in the universe. They remind us that consciousness remains one of the deepest mysteries in science, and that this mystery might be the key to understanding everything else. The quantum consciousness revolution is still unfolding, with new discoveries and insights emerging regularly from laboratories around the world. As our experimental techniques become more sophisticated and our theoretical understanding deepens, we may be approaching a fundamental shift in our understanding of mind, matter, and reality itself. But even now, without all the answers, we can appreciate the profound mystery of consciousness, your consciousness, which makes this very contemplation possible. The fact that matter can become aware of itself, that the universe can know itself through minds like yours, remains one of the most remarkable facts about existence. As you rest tonight, consider that your consciousness might be participating in the ongoing creation of reality. Every moment of awareness, every conscious choice, might be contributing to the universe's evolution, helping to actualize possibilities from the quantum realm into the definite reality we all share. Your mind is not separate from the cosmos. It might be one of the ways the cosmos comes to know and create itself. Sleep well, knowing that your consciousness is part of something far grander than individual experience, a cosmic adventure in awareness that spans space and time. And when you are ready to explore even deeper mysteries, join me next time for How Your Brain Creates a Reality That Isn't There, where we will discover that the solid, definite world you think you inhabit might be far more malleable and observer-dependent than you ever imagined. Until then, dream of quantum possibilities, and remember that in the strange world of consciousness and the cosmos, the dreamer and the dream might just be one and the same.